Hello, my name is William Phillips, and I am an undergraduate electrical and computer engineering student at the University of Rochester. As a research assistant with the Human Motion Lab at the University of Pennsylvania, we validated the open source software Deep Lab Cut versus traditional motion capture in the study markerless motion tracking for human subjects using open source deep learning software. First, some background on our study. Motion capture has long been standard in the field of biomechanics. At its core, it involves placing reflective markers on a subject and using specialized cameras to reconstruct the location of said markers throughout a given time frame. However, this equipment is expensive, and the marker placement is difficult and requires specialized training to do correctly. All this adds up to needing to do motion tracking in a lab setting. COVID has only made this process more difficult, as it is now unsafe to bring in subjects to collect data. The advent of artificial neural networks and deep learning provides researchers with new tools to collect data in different environments for a fraction of the cost. An example of a free open source software package that allows for human motion tracking is Deep Lab Cut, created by the Mathis Group and Mathis Lab at EPFL. To help train and validate a model, we leveraged the MoV dataset, consisting of 90 subjects with motion capture and commercial video collected by researchers from York University, Queen's University, and the University of Pennsylvania. To train our motion tracking model, we used a training set of 69 subjects. A k-means clustering algorithm chose 6 coronal and 6 sagittal frames from the subjects. The four authors then labeled these images with 19 landmarks, with 5 subjects being shared between the authors to test for agreement between labeling. The neural net chosen for training was ResNet 50, the workhorse model of Deep Lab Cut according to its creators. It took roughly 8 hours for training to complete on the HML Labs computer. Next, the test set of 15 subjects was passed through the model, and the data from Deep Lab Cut was synchronized with the motion capture data from the MoV dataset. Finally, hip, knee, and ankle angles were calculated for both traditional motion capture and Deep Lab Cut. The results were compared using coefficient of multiple correlation and root mean squared error. The results can be seen on the screen with motion capture in gold and Deep Lab Cut in black. There was strong agreement between the output of Deep Lab Cut and traditional motion capture technology. Our study shows that open source software combined with publicly available data can match the output of much more expensive and restrictive motion capture systems. Qualitatively, anyone can see that the videos on the screen are impressive. But benchmarking versus the gold standard of the field allows for researchers to be more confident in their findings. Again, my name is William Phillips, and my contact information can be seen on the screen. Thank you for your time and have a great day.